Welcome to the binomial series. Today we'll be using the binomial theorem to expand binomial expressions. We just learned how to expand binomial expressions using combinations. Today we will learn method number 3. Using the binomial theorem. What does the binomial theorem state? The binomial theorem states that if a plus b raised to a power n is equal to a, the first term, is raised to the maximum power, which is n, plus, notice that the a reduces by 1 in power in the second term, and b is raised to power 1. And then we've got n divided by 1 factorial. This is the second term. The second term, we had n here, which is this one. Notice we are multiplying it with n minus 1 divided by 2 factorial. The a there is now reduced further by 1, and the b increases by 1, so it has become b raised to power 2. And then we just continue like that. We had n minus 1 here, which is this one, n minus 1, and then we've reduced n further by 2, and we've divided everything here by 3 factorial. And then our a, the first term, we subtract n by 3, and b we raise it to power 3. Okay, now this is just a pattern. It's just making a pattern here. The first pattern is that we've got 1 factorial here, 2 factorial there, 3 factorial there. So the fifth term will have 4 factorial, and then we've got n, then n minus 1, then n minus 2 there, n minus 3, and then we'll continue with n minus 4, n minus 5, and so on. And b, we're simply increasing it by 1. So we've got 1 there, 2, 3, 4, and 5, and so on and so forth. This theorem is able to expand positive, negative, and fractional powers. Okay, so the first expansion that we did, we used the Pascal's triangle, and note that the Pascal's triangle is only able to expand binomial expressions which are raised to whole numbers. We only had whole numbers. The second method that we used combinations. And in combinations as well, we were only able to expand binomial expressions which are also raised to whole powers. But with this theorem, we can raise powers here which are whole numbers. We can also expand powers which are fractional. We can also expand powers which are negative. Example: expand the binomial expression below using the binomial theorem. So here we are. We've got x plus y raised to a whole number. We can use the binomial theorem to expand this expression. Okay, so if we want to expand x plus y raised to power 3, we simply compare with what we have in the binomial theorem. So in comparing, our x is taking the position of where A is, y is taking the position of where B is, and 3 is taking the position where n is. And so in substituting into the binomial theorem, we're simply going to have this x raised to maximum power, which is 3, okay, and then it will keep reducing. So we're going to reduce it. X 3 minus 1 will give us x to the power 2, and then 2 minus 1 will give us x to the power 1, and so on. So we're going to have 1 minus 1, which will give us x to the power 0, which is supposed to be here, but we haven't included it because x to the power 0 is 1. And for our y is raised to the power 1, and then we keep increasing to y to the power 2, and finally y to the power 3. Remember, we cannot go to y to the power 4 because the maximum power here is 3. And then of course we've got n, and then we've got n minus 1 divided by 2 factorial, then n minus 1, n minus 2 divided by 3 factorial, and so on and so forth. I haven't included 1 factorial here because when we learned factorials, we saw that 1 factorial is equal to 1, so we're simply going to have n divided by 1 here, which is simply n. Okay, then further we're simply going to substitute the values of n. The values of n here, n is equal to 3, and n here is 3, then 3 minus 1, 2 factorial is simply 2 times 1, and we've got n there, which is 3, n minus 1, 3 minus 1, n minus 2, 3 minus 1, and 3 factorial here is 3 times 2 times 1. Okay, and in further simplifying that, we're simply going to have x raised to the power 3, 3x squared y to the power 1, and then we're going to have 3 multiplied by 2 divided by 2, which when we simplify will simply be 3. And here we've got 3 multiplied by 2 multiplied by 1 divided by 3 multiplied by 2 multiplied by 1, which will simply give us this one here. The whole lot of that will just cancel to 1. And in completing it, we can write it this way. We can write it as x raised to the power 3. The 1 there has disappeared because it doesn't change. It's the same. And the same for x raised to the power 1 there. Will simply give us x. And the 1 there, 1 multiplied by anything, will simply remain that. Okay, so exercise, use the binomial theorem to expand the following. So please pause and practice using the binomial theorem to expand these. If you need further reference, please you can go to John Bed, Engineering Mathematics, 6th edition. Thank you.